Assalamualaikum and welcome to the channel. My name is Rusyidah binti Boestami from Politeknik Sultan Idris Shah. Have you ever noticed your cooking oil changing color or developing an unpleasant smell? That's oxidative deterioration in action. This process, triggered by exposure to oxygen and sunlight, is particularly problematic for commonly used cooking oils because of the susceptible double bonds in their chemical structure. The result? Consumers prematurely dispose of oil, leading to huge environmental issues like drainage system clogs and increased pest activity. We need effective ways to stabilize these lipid-based products and extend their shelf life. Historically, the food industry relied on synthetic antioxidants like BHT and BHA to delay oxidative damage. However, the use of these synthetic additives is now restricted due to evidence linking them to potential negative health effects, including liver damage and even carcinogenesis. This has fueled a rising interest in natural antioxidants derived safely from plants. Our research investigated two significant local plants from peninsular Malaysia, Garcinia atroviridis, or Asam gelujor, and Tamarindus indica, tamarind. These plants were selected because they are already known to contain compounds that exhibit strong antioxidant properties. The primary objective was simple: to characterize the physical properties of their oils and determine their effectiveness as natural antioxidant agents, specifically aimed at stabilizing waste cooking oil. The motivation for this study stems from three critical gaps in current practice. 1. Need for shelf life prolongation. Identifying sources of antioxidant activity that can effectively prolong the shelf life of oxidation-susceptible products. 2. Resource utilization. Confirming the presence of beneficial compounds, specifically flavonoids and tannins, in Garcinia atroviridis and Tamarindus indica that confer antioxidant properties. These phenolic compounds are known to contribute significantly to in vivo protective effects and nutritional value. 3. Substitution of synthetic additives. Developing a reliable natural antioxidant derived from these plants to serve as a safer substitute for synthetic antioxidants currently restricted in use due to potential negative health consequences, such as links to cancer. How do you get these protective properties? We use the solvent extraction method, which is known for efficiently preserving the desired antioxidant traits. We employed two solvents to compare results: n-hexane, a nonpolar solvent good for oil extraction, and ethanol, a polar solvent highly effective for recovering polyphenols. The crucial compounds we were looking for were flavonoids and tannins. Phytochemical screening confirmed the presence of flavonoids in both Garcinia and tamarind extracts, using both solvents. These phenolic compounds are essential, contributing significantly to protective effects and nutritional value. To prove efficacy, we performed two key tests: the DPPH radical scavenging activity to measure their reducing ability, and the crucial peroxide value test, PV, which gives the first evidence of rancidity and primary oxidation. Waste cooking oil, the reference sample, showed a high PV of 19.889 mg per kilogram. Conversely, the extracts applied to cooking oil demonstrated substantial protective effects. Garcinia oil, ethanol extract, reduced the PV to 7.488 mg per kilogram. The blend of Garcinia and tamarind oil, ethanol extract, achieved a PV of 5.920 mg per kilogram. These results indicate that these extracts, particularly the ethanol-derived extracts, successfully maintained the PV below the maximum codex standard of 10 mg per kilogram, thus effectively delaying oxidation and prolonging the oil's shelf life. The novelty here is the creation of a naturally sourced, plant-based functional food additive capable of substituting harmful synthetic alternatives. This innovation presents significant commercial potential for the edible oil sector and food manufacturers looking for clean label ingredients. The value proposition is clear: these extracts reduce oxidation, prolong shelf life, and translate into reduced material waste and economic savings. Since both Garcinia and tamarind are perennial and widely cultivated in regions like peninsular Malaysia, raw material availability is sustainable. In conclusion, the extracts from Garcinia atroviridis have been successfully reduced the oxidation of the cooking oil after several rounds of frying process, but for Tamarindus indica extract did not successfully reduce the oxidation as it's still above the standard. Phytochemical screening test showed both samples contained flavonoids and tannins, except tamarind extract did not show the presence of tannins. The value of the peroxide value for cooking oil after the frying process is 20. Garcinia extract showed the value of 7, meanwhile tamarind extract showed the value of 17. Adoption of these extracts in food systems can address consumer health concerns and optimize product quality, establishing a foundation for future innovation and commercialization in the food sector. Registration and credibility. Researchers also want to thank my IPO for copyright products and notification number CRLY2025W09042. Get in touch with us. Let's do green innovation products together. From Politeknik Sultan Idris Shah, Sabak Burnham, Selangor.